Hey everyone, in this video we are going to be discussing how to measure arc length. Alright, so the first thing we need to talk about is what in the world is arc length. If I gave you 2 points along a curve, and in this case it's a special curve, it is a circle, the arc length would be the length along the curve between those 2 points. So it's important to distinguish that this is along the curve, because if I was just talking about regular distance, you would just use the distance formula, which is a straight line between these 2 points. But that's not what we're after. Okay, this distance is a little bit longer because it's curving. Okay, now it's actually quite challenging to figure this out. There's probably some fancy formula to do it, I'm sure. But we're going to be a little bit clever, and we're going to solve this problem using proportions. Now, in order to use proportions, they're going to have to give you a little bit of information in order for us to do that. Number one is they are going to have to give us the radius, so some kind of r radius. And number two, they're going to have to give us the angle between, or at least a way to figure out this angle between. So that way we can figure out this distance of this arc length. All right, so the strategy we're going to use to do this is with proportions. And so the overall idea is if I know this angle, theta, then I know that, or I can calculate at least, what percentage that makes up of the whole circle in degrees. So it's going to be theta divided by 360 degrees because there's 360 degrees in a circle. So I can figure out the percentage of this segment. And now all I have to do is figure out, well, I don't know what d is, but I can figure out the entire circumference or the entire distance around this circle. And so if I know theta, if I can calculate the circumference, and I know there's 360 degrees, then I can then cross multiply and divide to figure out d, what this distance is of this arc length. Okay, so we're going to solve using proportions. So let's see this strategy in action. All right, so let's go ahead and give some, we'll give our information here, and we're going to say, I don't know, I'm just going to make something up here. So here's a point, and here's another point, and we're going to go ahead and draw some lines between here because they have to give us some information, and so we're going to say this is actually a right angle. So this is 90 degrees, and let's just call this, I don't know, let's call this 5, and actually let's provide some units here. We'll say 5 inches is the radius. Okay. All right. So the real question is, what is this arc length? And we'll just call it x. Okay. And so what we're going to do is simply set up our proportions. So I know that this chunk of the pie, so to speak, is 90 degrees out of the total pie of 360 degrees. Right? So actually, you can kind of do that in your head. That's actually 1/4. It makes up 1/4 of the pie, but we don't really have to actually simplify it in order to solve this. But anyway, so we're going to set up our proportion. So that should be proportionate to the length of this arc, x, over the length of the entire circumference, c. C for circumference. Now we can calculate circumference. Let's go ahead and do it. So circumference, if you recall, is equal to 2 pi r. Or you could say diameter times pi, but a lot of times we're given the radius, so we'll say 2 pi r, which in this case is equal to 2 times, I don't even have to write this out actually, 2 times 5 is the radius, so that would be 10 pi. So I'm going to go ahead and plug that in, and now I have these proportions all set. So I'm going to cross multiply and divide. So 10 pi times 90, and then divide by 360 to get my x. So let's go ahead and bring up a calculator in order to do this. And let me go ahead and turn it on. There we go. All right, and so let's go ahead and calculate. So I'm going to say 10 pi, and pi is located right above this caret, so second pi. And then I'm going to multiply by 90. And then I'm going to divide by 360. And I'm going to round this to the nearest tenth. In this case, my arc length is approximately 7.9. So x is approximately 7.9. In this case, it's inches. Okay, let's do one more because these are tend to be pretty easy problems. They can't be too fancy after all. So let's go ahead and yeah, we'll give a little bit different information to start with. All right, so let's say, I don't know, they give us some information. They say the diameter is equal to, I don't know, let's say 36, and the radius, I'm sorry, not the radius, the angle, say angle, is equal to, that's just a little symbol for angle, not a very good one, but that's okay. Let's say the angle is, actually, let's do the, you know what, I'm going to draw this out. Let's do, because I want to give you, try to make you figure this out a little bit. So I'm going to say these are these 2 points. All right, we're trying to figure out this arc length. We'll call it x. And the angle they give you is actually the angle on the outside. I'm just going to, I don't know, make up an angle here. So let's just call this 300 degrees. Okay, so this is 300 degrees on the outside here. All right, so step one is I need, I don't technically need the radius. I can just use the diameter, but I'm going to go ahead and put the radius in here. So half of 36 is 18. And I didn't provide units, so let's just call this meters. But anyway, so this is going to be 18. And all we're going to do is set up our proportion, but I do need to know the actual angle inside of here, right? Because that's this piece of this pi. 300 is the outside. So I'm going to subtract 360 from 300, and I'm sorry, 300 from 360. And that means that this angle must be 60 degrees. So there we go. So I have the amount that this piece of the pi is making up of the whole. So that is 60 degrees out of the whole of 360 degrees. And now I can go ahead and I'll say set up my proportion. So this is proportionate to x over the entire circumference. Well, what is the entire circumference? Well, in this case, yeah, it's 2 pi r, but or the diameter times pi, right, which is 36. So that is going to be equal to 36 pi. And so I'll plug that in. Now we're going to bring up our calculator and we are going to calculate. Again, I will round to the nearest tenth. So we will cross multiply and divide. So 36 pi times 60 and then divided by 360 and enter. And we get approximately 18.8. So x, or the arc length, is approximately 18.8 meters. All right, so there we go, you guys. Calculating arc length can be pretty simple, provided they give you the correct information, right? We can be somewhat clever, come up with some proportions, and then solve for that arc length.